Hi folks, welcome back on the Salty Ends. In many places in the world, when you live on the coastline, you can witness the tide coming in and out during the day. And in some places, they develop tidal range energy to produce electricity in a more sustainable way. But today we're going to talk about an upgraded technology developed in Norway, and Arne Kollandsrud, who is the CEO of TIDETEC, will present to us. So let's check it out.
Hi.
Hi, Arne.
Hello. How are you?
Good, and you?
Yeah, I'm fine.
Well, Arne, welcome on the Salty Ends. And so you are the CEO of TIDETEC. And
yes, that's right. I'm CEO in TIDETEC. I've been there for 5-6 years.
I would like to know a bit more. First, to talk about your story and why you want to develop TIDETEC. What's your inspiration?
I grew up with the father making prototypes in a workshop in our house, and I was very into technology and model airplane and all of that. So I've always been very interested in technology. But later I was very fond of playing trumpet as well, and so my career took a different direction, and I went as a professional trumpet player. But I always had this connection and played with technology with my father and so on. And then as he grew older, and he had this one of his great things, ideas, was this TIDETEC concept, and I really wanted to test if that was viable and if it was a good idea. He had a patent, and I wanted to test this patent. So when he asked me if I wanted to give it a try, I said, okay, if you pay me, and I play a bit less trumpet, and I will do some re-education.
Right.
And try to get an expert team believing in this, and if I could get that, then I would pursue it. What I did was, after some re-education within entrepreneurship and innovation, and suddenly I was part of writing a book about innovation also. So it was very fun.
Nice.
that changed, and then I applied for a Eurostar project. That is a European soft funding program, and we were actually not the first year, but the second year we were granted, and that gave us almost 2 million euros in budget over a 3-year project, and it was together with some of the best low-head turbine engineers in Europe at the Munich Technical University in Germany. And we also had some partners from UK to be close to the market in UK. Okay. And we had also some civil works engineering team from Hamburg in Germany. And with those money we could start really getting proof of concept, and it gave us definitely the proof of that this is a very logic way to harness tidal range energy.
All right. Well, before talking about the solution that brings TIDETEC, I would like to exchange with you about the tidal range energy throughout the world. Like, what's the potential and probably also the barriers to this market?
The potential is quite large. It's a big potential, but it is connected to the sites, the localities where you have high difference between lowest and highest tidal head. UK, especially the west coast of UK, France, Chile, Asia. In Asia you have some parts of China, but also South Korea. Okay. And it's also some Russian sites up north has been in discussion to utilize this kind of. There's a testing facility there up in Krislaguba, but mainly the UK is the market that we think are coming first, and also Canada has a power plant from 1980 in Annapolis, and the reason it's not only the tidal head should be as high as possible, because that makes the energy much more concentrated, of course, but also it shouldn't be too deep.
So you have to build kind of bridges near the coast, so it's mostly coastline.
So you have an impoundment, so you encapsulate an area. That's why we call it a sea basin, ocean basin, or ocean estuary. And then you can have a pond either close to the coast, and close off a part of the coast. Then you can also have flood defense, or you could have an offshore lagoon, or you can also just build a barrier. And sometimes you are going to build a bridge anyway, and then you can make an energy bridge out of it, having the turbines underneath. And that's what they did in 1967 in La Rance in France.
And so, so this tidal range concept are working since few years. My question is, from these technologies, what are the barriers these technologies actually?
The barriers are that you have to construct. There are lots of civil works before you produce any megawatts. Offshore wind or also floating wind or solar, you are producing as soon as you put it up and construct it. Here you have to make, either you can make a tidal lagoon or a barrier, or you can use existing infrastructure like a dry dock or a tidal basin, and then put a turbine where it suits. So it's a combination, but and the potential, like in UK, is more than 300 terawatt hours a year. You can supply 15% of the energy need in UK by this method. But the barrier is you have to construct. It's a upfront payment is quite high, but as soon as it's constructed, then it produces the cheapest energy you can have. Like the La Rance plant in France is the lowest cost of energy in France.
Now, and that all the barriers. So a tidal energy system is you create a basin and you have a turbine, and thanks to the tides, you have.
So you if you can close off the water between the ocean and the estuary or the lagoon or the basin, then you can hold when the water goes down, and then you have a head difference. And you let the water go through turbines, and then you close off, and the water in the estuary, in the ocean raises again, and then you open. And by that, then the same goes through the same turbines, and that's why we also call it two-way hydropower, because it's like a run-of-the-river hydropower plant, except that the river is going backwards half the time. That's why you need special equipment, and that's why TIDETEC has patented and developed a special turbine solution.
Exactly, coming to that, why, how TIDETEC is bringing a upgraded solution to this?
Yes, normally you use what you call Kaplan-Bulb turbines. That means you have turbines that is pressing the water to increase the flow, and just the same as traditional run-of-river turbines. Talking low head, large machines, instead of having a very advanced triple regulated machine, we can make a simple one-way turbine, and we put it in a turret. so that
Nice.
it can always face in the right direction towards the currents, the stream. And that is, and to my father's surprise, he could patent that. And we have, now we have 3 patents, one from the Eurostar project and 2 from the Eurostar project and 1 from my father initially. And then this makes it possible to have a turbine that it's optimized not only for high discharge and fast emptying of the basin, but also for pumping, because you can do some pumping in this production regime. And by doing that, you can increase the overall production by 15%, and you can also meet the environmental constraints. So that means that the wetlands and mudflats and so on, they are still having the same tidal range.
So that's one of the benefits, but there is also other benefits I read about.
If you want to compare, you use levelized cost of energy for wind and solar, and in UK, offshore wind is about 50 pounds per megawatt, and floating is much higher at present stage. Tidal range can, in the biggest projects that are now projected, like the Mersey project, can reach levelized cost of energy levels to compete with the offshore wind, and this is predictable energy. So it's very needed, and you can even connect on the west coast, for instance, in the UK, you can connect several of the projects to each other, so they are linked, and then you can have continuous production. That means you have baseload renewable power, and baseload is very important now when they are facing in so much intermittent. So that's one great advantage of this, and you can also you can predict when to produce. If you have a single project, single power plant, you can predict when to produce, but you can also adjust the production 1 hour back and forth, so that you can wait for an hour to wait for the electricity price to drop or to raise, and follow that. And another aspect is on a coastal lagoon, you are covering flood defense for the area that is covered. So this is also possible to combine with flood defense. You can combine it with floating solar. You can also combine it. It's very good for clean power to feed into hydrogen production. So a part of the energy mix, it can be very substantial. And in UK, they are closing off all the coal, but then they are losing the base load. So they really need this base load to balance the grid.
So yeah, there's many beneficial ways to see that. And I read some information about your company, and I saw that you're also really into sustainable way to implement, because there's a civil work and you really want to make it really respecting the environment while constructing.
Yes. It's a bit technical on the turbine side, but we know it is more fish friendly. It's also environmental friendly because we have a modular approach, so that you never have to close off the water exchange in the basin. So, and you have a modular, you can produce the powerhouse one place in concrete, and then you can bring it as a gravity-based structure and bring it in place. An offshore lagoon, for instance, it's not much higher than you can hardly see it, and that's it. And the rest is underwater; you can't see it, and it lasts for 100 years and blah blah. So they are quite different from offshore wind or solar, but I think in the future we are very much dependent on utilizing all kinds of energy, like tidal stream, tidal range, solar, hydropower, hydrogen for storage, pump storage. You can also, as I mentioned, on offshore lagoon, you can also use it as low head pump storage.
And talking about the future, what are the next steps for TIDETEC?
Next steps, it's very, we have now build up a team of engineering capacity and also commercial executives. We are in the process of that, and we have strengthened the board and so on, and also we are now a very international team. We are on the engineering side. We have a Russian, we have a Greek, Dutch, and I'm Norwegian, and we are collaborating very much with UK partners. So it's a very international team, and what we are doing now is we are developing the technology, and we are preparing and doing a pilot project.
Nice.
In UK, we can use a left dry dock. It's no more in use.
Okay.
So we can use it as a demonstrator for the whole concept.
Nice.
And that's what we are working day and night for now, to reach having something. Our goal is to have metal in water, as we say, within 1 year from now. That means beginning of 2022.
Okay.
And the reason why we're so much in a hurry is that the DCO, the design consent orders, that locks the kind of the technology chosen in the coming projects in UK. Those processes are expected to happen in 2022, and we want this pilot project to prove our we have the proof of concept, but we want to prove the bankability. So we want to explore these details and solve them in the pilot project. We're not expecting too much trouble, because we have already tested it in laboratory, the model turbine in Munich, and also tested a prototype of the turret, of the turning mechanism in real conditions in the ocean. So, but now we're putting it all together, and we will do some fish friendliness testing. We will do some optimization of the production regime and test pump storage. Test how to maybe we can utilize the produced energy for hydrogen production, or as a EV charger station, or we will do some nice things about that.
Awesome.
So that is one thing we are doing, and another thing that showed up now is a interesting demonstrator project. It's a Newton classroom. It's educational outside demonstration of, in this case, it will demonstrate a small tidal lagoon up north in Norway. And they are building this underwater restaurant with glass walls, so you can see the turbine, you can see the turret, but it's at a very early stage, so we don't know if we can get money, but they hope so, and they want to use our turbine. And we also are looking into some retrofitting. And then the full-scale, bigger projects are in the pipeline, like in South Wales. We can utilize the existing infrastructure, like tidal basins. Some of those projects can fly without any subsidies. So we just have to arrange it in the right way together with our UK developing partner, and also together with some industrial partners that wants to use the energy. One project is about producing tidal power for producing green steel, for instance.
Many projects, and so you have like the implementation of kind of already on-site civil work and bridges as well.
Yes, so if you can combine all of these, then the upfront cost is already paid. So that's, if you can have that play together, then it's a very a good financial model.
Probably you guys that listen to us, probably you think about some places in the world that could use this concept. And so how we could help TIDETEC to move forward?
Well, we are of course we haven't the total finished product. We have done it in small scale, and we are scaling up. Of course, we need some developing capital, equity. So investors are welcome, of course, industrial partners, and we also want people to, if they think that this could be a possibility, please let us know, and we can, because we are very good at measuring and estimate annual energy production versus the cost versus the levelized cost of energy on the different sites. It varies from very low, below offshore wind, even below fixed offshore wind also, but and then it goes upwards. So it could be very nice to have some input from public. Follow us on LinkedIn or on Twitter, or and we will try to. We now have more and more news, so we will try to be more active on the PR. So.
Yeah, that would be great to know how the pilot goes in the UK. Thank you for all this information and inputs, Arne.
Thank you for letting us share it with you. That's very nice. And I really appreciate your work also, Arne. With your hands. So, of course, people have to follow you and support you.
We'll work on that. Thank you. I want to ask you, what do you wish for the ocean in the future as you close to it?
From the there was, I think it's from Apollo 13, the movie. There's this picture of the Earth, and I don't know if it's from the movie but anyway, one of the astronauts. They took this famous picture of the Earth, and you can see this tiny atmosphere.
True.
And he said he never looked at the atmosphere in the same way as. I mean, it's limited, and the vast ocean, it's also limited. Now we know that we are doing wrong things. So my hope for the ocean is that we can really respect it, and play in collaboration with the ocean as a kind of a living thing, not as something that we just can hide things in, like the plastics or whatever. So I think the transition, the climate adaptation, everything, in the bottom we have to respect the nature and play with the nature, not against it. So we have to find the best solutions, not the only one solution. There are so many. So I think my hope for the ocean itself is that the humans can be better to respect it, and so we can turn the climate change to be positive.
True. Wow, thank you. All right, thank you. And so, but I have a question. You still play your trumpet, don't you?
I do. So if you want, I could play a trumpet fanfare for the ocean.
So as you see, there's a lot of solution and improvements, and we can have a lot of optimism about solutions that people created and invented. And so guys, share if you liked the video and you think people might be interested about the TIDETEC concepts. I will also invite you to bring solutions if you have some, like if you have ideas, don't hesitate to share with us, and we'll be pleased to make any publication or video on the solution that you can propose to us. I wish you a great day. Thank you for your time, and I'll see you next time.